Okay, so in class the other day, some of us didn't get to this problem. So what we're going to do is we're going to go through this and we're going to try and simplify it. Now, what I'd like for you to try and do once again is I'd like for you to pause the video, maybe try and figure it out, work with your partner, watch the video, maybe see a few steps. After you see those few steps, maybe try again on your own. Kind of work through it that way, and I think that's a good way to learn through these videos. Pause, and if you have a question, pause the video, write down what your question is, like how did I do this step, what was my, I didn't understand what I was talking, what Mr. Thornley was talking about here. So then when we revisit in class, you can flip to that and just ask me your question. We'll go ahead and clear it up. So I'm going to go ahead and get started, and I'm going to go ahead and clean that up because I didn't mean to do that. I'm going to go ahead and I'm going to move this kind of to the center here. So it's right up here. And I'm going to have a couple things on either side. So on the one side, I'm going to have my Pythagorean identities. Right, we got sine squared theta plus cosine squared theta is equal to 1. And remember, we manipulated this. And the way that we manipulate it is, if I go ahead, I need 1 plus tangent x. So that means if I divide everything, it's hard to write small on this, so just bear with me here. But hopefully you're seeing that I'm dividing everything by cosine, right? So that would be tangent squared theta plus 1 is equal to cosecant squared theta. And that's how I came up with it. So when I see these kinds of things, I'm going to focus on these Pythagorean identities right here, and I'm going to see if I can actually substitute that in. So that's actually my first step. So I'm going to go ahead and do that. And that's cosecant squared theta. That's supposed to be a square. Pen's not the best here. Okay, there we go. And then I got 1 minus cosine squared to 2x, right? Let me erase that. Mr. Thornley's just not doing well here. So we got cosecant squared x, right? Because we got that from our Pythagorean identity. And then, I got this guy right here. Now, on the other side, we got all these different cosine 2 alpha identities, right? We got cosine squared alpha minus sine squared alpha. X alpha, same difference, the variables are interchangeable. The other one I got is 2 cosine squared alpha minus 1, or 1 minus 2 sine squared alpha. These are all my choices to substitute. Remember in class what we talked about was, let's go ahead and focus on this guy right here. Okay? He's going to be replaced. And the proof problem that we did in class was nice because we knew what the top ended up being, so we kind of worked towards that. But this problem, what we're going to focus on is this is a positive 1 right here. So what I want to do is I want to look at these guys and say, okay, what can I plug into this blue box right here that's going to cause the 1s to cancel out? Got to remember that I have to look at opposites. So I have a positive 1, and hey, if I got a negative 1 here with the negative in front, that's going to make that guy positive. Well, this guy, if I plug this guy in, I'm actually going to get a positive 1, so the 1s will cancel out. So what I'm going to do is I'm going to use the 1. I'll put ID. That cancels the 1. That is going to be what I'm going to look for. Okay? It's a good approach to these problems. So I'm going to go ahead and I'm going to put down cosecant squared x, right? We had that. All divided by 2. Give me a second here. I'm going to do some separation here. Just kind of separate that so that doesn't get mixed up. And then I have our, too thick, but we'll leave it. That's okay. I have 1 minus, and then parentheses 1 minus 2 sine squared x. And then I got the parentheses on the outside. Okay, so now this negative distributes and distributes, so what's going to happen here is we continue this cosecant squared x isn't changing. I distribute the negative, so I get 1 minus 1 plus 2 sine squared x, all divided by 2. The ones cancel out. I could ignore the plus. I get cosecant squared x. I have 2 sine squared x. The 2's cancel out. It's all multiplication, so that's okay. And we can go ahead and move this guy just a little bit. And this is going to equal, well, cosecant is 1 over cosine squared x sine squared x over 1. This is going to equal sine squared x over cosine squared x. And that, hopefully, you're saying is equal to tangent squared x. Whew. Okay, let's see if we can go back up here just to kind of revisit without messing things up. Basic idea is, I know this might be hard to see, but I don't want to... There we go. So just to revisit, if you need to, we looked at this guy. You're going to maybe want to distribute, and I wouldn't do that. I would look at this and recognize I got my Pythagorean identity. I look at this, look to cancels the ones, and see what you got there, and then maybe distribute. Because when you distribute, this is going to be a mess. And the reason I know it's going to be a mess when I distribute is I got a double angle and a single angle. Not going to be fun. Okay? So this video kind of went long. Hopefully some of you fast forwarded a little bit because you knew what was going on. Saves you a little bit of time, which is great. Don't have to watch the whole thing if you don't have to. And we'll have one more video after this.